Welcome students. Now let us know how a equipotential surface is being created. Suppose you are moving a charge from this point to this point. Okay, this is one charge Q and I am moving from this point to this point to distance R. Okay, if that same charge, if I will move from this side to this side with same distance R, from same distance R, okay, same distance R inside, same distance R outside, and if I will join all these points, what it will make? It will make a sphere, right? And the most important point is that the potential at each and every point will be same. Why? Because the distance is same, so the work done is also same. Welcome students. Let us know what is equipotential surface. So let us see the definition. Equipotential surface is that imaginary surface on which at every point the potential is same. Okay, like this. Suppose this is my equipotential surface, okay, and this is my one potential, one point, suppose point A, and this is my point B. Okay, if I will move one charge from this point to this point, okay, what should be the difference? As the potential is same, it should be your V2 minus V1 equal to 0, because both the V2 and V1 are same. So what should be the work done? The work done is also 0. As the potential is same, so the V2 minus V1 equal to 0. So work done on unit charge is 0 for a equipotential surface. So let us find potential at the axial line. Like electric field, we have found the two derivation of axial line and equatorial line. Here also same. Let us study about the axial line. So here one dipole is present minus q to plus q, and at this point P, at a distance from the midpoint R, we want to find out the potential. So what should be the distance? The distance from plus q to R is R minus L, because this whole total is R, midpoint to point P distance. So what is plus q to the point distance? Plus q to the P distance is R minus L, R minus L. So what is minus q to P distance? R plus L. This you have did already, right? So let us find out what is potential. Potential due to minus q equal to minus 1 by 4 pi epsilon naught into q by R plus L, right? And potential due to plus q is q by 4 pi epsilon naught R minus L. Here only one change is there which you have to remember. Don't forget, your potential is a additive quantity, because potential is a scalar, right? So V equal to V plus q plus V minus q, right? So q by 4 pi epsilon naught take outside, so you will get 1 by R minus L minus 1 by R plus L. So okay, if you will solve, this will be your q by 4 pi epsilon naught. Okay, so this will be, if you will solve this one, R plus L this side, R minus L this side. Okay, if you make it subtraction, and this side if you multiply, it will be R square minus L square. You will get the answer 2L by R square minus L square. What is q into 2 into L? Dipole P. P whole divided by 4 pi epsilon naught into R square minus L square. As we know, your R is more greater than your L. What is your R? R is more greater than your L, right? Your R is more greater than your L, right? So L will be neglected. So if L will be neglected, what is your answer? P by 4 pi epsilon naught R square, right? This is your answer. Now let us think why potential is additive. Suppose one is at this point P and what is at this point Q. Okay, let us move a charge. Okay, let us place a charge here and let us move. If I will move this one at this point, if I will move one charge from Q point to this midpoint M, I will get one potential, right? When I will go further from this point to this point, again I will get another potential. So what will happen? This potential is what? Work done upon a unit charge. This is also further work done upon that particular charge. So what will happen? This is nothing but, if I will take the name V1 and V2, this will be simply V1 plus of V2. Everywhere this system has to be followed, right? So let us find the derivation for potential at equatorial line. So this is the dipole minus Q plus Q with the distance L and L from the midpoint, and let us take a point at the equator P. Okay, point P at the equator, and this distance is R. So if this is R and this is L, you know what should be this one? Root over of R square plus L square. This side also root over of R square plus L square, but I have written the same thing only, R square plus L squares whole to the power half. You can also write down the same thing, not an issue. Okay. Now, so what should be the addition of the potential? V plus Q is how much? This much, right? Your V plus Q is Q by 4 pi epsilon naught root over of R square plus L square. This one, this is plus Q. And what should be the, at equator, what should be the answer? Your potential, Q by 4 pi epsilon naught root over of R square plus L square. Okay, due to V minus Q, okay, this is what? Net V net equal to V plus Q plus V minus Q. So what should be your V minus Q? V minus Q is nothing but minus Q divided by 4 pi epsilon naught root over of R square plus L square. So what will you get the answer? 0, right? Okay. So if you have not got any answer at equatorial line or at a point at the equator, so what should be the other technique? In your ISC examination or in your any examination, one question will be asked that let us take a point other than your equatorial line, right? And let us find out their potential, right? Suppose this derivation is named as potential due to a dipole at any general point. Potential due to a dipole at any general point. So let us take a dipole first. Okay, let us take it here. Okay, this is minus Q, this is plus Q, and let us not take the point P at the equator, let us take somewhere at here, point P. Okay, and you know it very well, from midpoint to the distance is how much? This is the midpoint, and midpoint to this distance is nothing but R, right? Now let us join these 2 points also, minus Q2 plus Q, sorry, P, and P2 plus Q here. Okay, now how to solve this kind of question? Okay, how to solve this kind of derivation? See, suppose a very simple technique, two thread is given to you like this, and somebody has asked the find out the length of this thread. So what will you do? You will just make this thread join with this thread, and after that you will calculate this distance, right? And easily you can calculate. The same technique what I have drawn here, a perpendicular, right? The same technique I will apply here. I will draw a perpendicular like this. Okay, and let us take this distance as x, and you know it very well, these distances are L, and this angle is theta, right? So this is nothing but, now my this line is equal to my this line, right? This you can perform because your dipole is a very small quantity, right? So if this is L, this is x, what is your base upon hypotenuse? This one is 90 degree, right? So what is your base upon hypotenuse? X upon L is equal to cos theta. So what is your x? X upon L equal to cos theta. So what is your x? L cos theta. So this side is your L cos theta. What is this? X equal to L cos theta, right? So what should be the length of this one? This total is R. This to this is L cos theta. This line is similar to this line. This line is similar to this line. So what should be the answer of this one? What is the length of this side? This is R minus L cos theta. This is quite tricky, and you have to remember R minus L cos theta, right? So what should be this one? Here I will extend, okay, in order to make this one similar to this one, what I will make? I will extend this one, same I will make the perpendicular. If this angle is theta, this angle is also theta. If this side is x and this is L, the same I will apply. This will be my L cos theta, this to this. So what is the side? This side length is equal to my this total side length. Now my these both lengths are same, right? Which length? This length and this length, right? This length. Okay, so what should be its length? Total length is this to this is R, and this one is L cos theta. So total is R plus L cos theta, right? This figure you have to draw. Now let us see the full derivation. The derivation is potential due to dipole at any general point. Okay, so V is what? V minus Q plus a V plus Q, right? We are writing like this. So for that one, for V minus Q, what we will get? Minus Q by 4 pi epsilon naught 1 by, and the distance was what? R plus L cos theta plus 1 by 4 pi epsilon naught Q by R minus L cos theta. This is for V minus Q, okay, and this is for V plus Q, right? And potential is always additive in nature, okay. And why it is R plus L cos theta, you can see the figure, right? For minus Q charge, okay, the distance is R plus L cos theta, right? So if you derive this one further, this is Q by 4 pi epsilon naught 1 by R minus L cos theta minus 1 by R plus L cos theta. So you have done so many times, R plus L this side, R minus L cos theta this side, and this will be R square minus L square cos square theta, q by 4 pi epsilon naught outside. So this is q into, if you neglect all the things, you will achieve q into 2 into L cos theta by this much. So you know it very well, your L is always more less than R, so you can neglect your this term. So you will get q into 2 into L is what? Dipole moment P cos theta by 4 pi epsilon naught into R square. So this is the answer, and this is the full derivation, right? Thank you.